Welcome to my channel, and today we will discuss some definitions of modern algebra. So आज हम सॉल्वेबल सीरीज़ के बारे में पढ़ेंगे. सॉल्वेबल सीरीज़ की डेफिनेशन देखते हैं. अ ग्रुप G is called solvable if we can find a finite chain of subgroup G is equal to n0 is a superset of n1 is a superset of n2 is a superset of so on is a superset of nk is equal to E, such that each ni is a normal subgroup of ni minus 1 and each quotient group ni minus 1 by ni is abelian. The above series is called solvable series. इसके कुछ एग्जाम्पल्स हैं. पहला देखते हैं. एवरी अबेलियन ग्रुप इज सॉल्वेबल. इसका प्रूफ है. लेट जी बी एन अबेलियन ग्रुप. टेक n0 is equal to g, n1 is equal to e, be two subgroup of g. Then g is equal to n0 is a superset of n1 which is equal to e is a solvable series for g. Now n1 is equal to e is normal subgroup of n0 is equal to g. Now for g, small g belongs to g and e belongs to n1. G belongs to G inverse, so G inverse is equal to E, which is belongs to n1. Now G inverse E G is equal to G inverse G, which is equal to E, which belongs to n1. Then G inverse E G belongs to n1. N is normal in G. G is abelian. The quotient group n0 by n1 is equal to GE is also abelian. Hence G is solvable group. हम दूसरा एग्जाम्पल देखते हैं. एवरी सब ग्रुप ऑफ सॉल्वेबल ग्रुप इज सॉल्वेबल. इसका प्रूफ है. लेट H बी अ सब ग्रुप ऑफ सॉल्वेबल ग्रुप G. Then we shall prove that H is solvable. Since G is solvable, so it has solvable series. Is that there are subgroups n0, n1 and so on nk of G such that G is equal to n0 is a superset of n1 is a superset of n2 and so on is a superset of nk which is equal to E, and each ni is normal in n I minus 1 and ni by ni minus 1 is abelian. H intersection G is equal to H intersection n0 is a superset of H intersection n1 is a superset of so on is a superset of H intersection nk which is equal to E. H is equal to H0 is a superset of H1 is a superset of H2 and so on is a superset of Hk which is equal to E, where Hi is equal to H intersection Ni, where each Ni is normal in Ni minus 1 and so H intersection Ni is equal to Hi is normal in H intersection Ni minus 1 is equal to Hi minus 1. Now we define a mapping phi such that hi minus 1 onto ni minus 1 by ni minus 1 by ni by phi x is equal to x ni. X belongs to h I minus 1. X is equal to h intersection n I minus 1. So x belongs to n I minus 1. So x ni belongs to ni minus 1 by ni. Since mapping is well defined, so first है phi is onto. For every x ni belongs to ni minus 1 by ni. Hence a unique x by definition of phi x is equal to x ni. Second है phi is homomorphism. So x comma y belongs to hi minus 1, x belongs to x ni and y belongs to y ni. So xy is equal to xy ni which is equal to x ni dot y ni, and it can be written as phi x dot phi y, since phi is homomorphism. If x belongs to kernel phi, which implies that phi x is equal to ni by definition of kernel. So x ni is equal to ni by definition of phi. So x belongs to ni and x belongs to h I minus 1, which is equal to h intersection ni minus 1. Here ni is a subgroup. So x belongs to ni and x belongs to h. So x belongs to h intersection ni. Here x belongs to hi. So phi is equal to hi by fundamental theorem of homomorphism group. Hi minus 1 is equal to hi minus 1 upon hi is equal to ni minus 1 upon ni. So ni minus 1 upon ni is abelian. Now hi minus 1 upon ni is also abelian, so h is solvable. Now there is another theorem. A group G is solvable if and only if G to the power k is equal to e for some integer k. Solution है, let G to the power k is equal to e for some integer k. We have to prove that G is solvable. Let n0 is equal to G, n1 is equal to G dash, and n2 is equal to G, G square, and so on nk, which is equal to G to the power k, which is equal to e. Then G is equal to n0 is a superset of n1 is a superset of n2 and so on, which is a superset of nk, which is equal to e. इसको हमने equation number 1 नाम दिया. We have to prove that equation number 1 is solvable series by the theorem. If G be a group, then G dash is commutative subgroup of G, then G dash is normal in G. So Gi is equal to Gi minus 1 dash is normal subgroup of each I. Also Ni minus 1 by Ni is equal to Gi minus 1 upon Gi, which is equal to Gi minus 1 upon Gi minus 1 dash. By the theorem, if G is a group and G dash is a commutative subgroup of G, then G by G dash is abelian. So we can write Gi minus 1 upon Gi minus 1 dash is abelian. Therefore, Ni minus 1 upon Ni is abelian for each I. Hence, equation number 1 solvable series for G, and thus G is solvable. Conversely, let G be a solvable. So we have to prove that Gk is equal to E for some integer k. G is solvable, so it has solvable series. G is equal to n0 is a superset of n1 is a superset of n2 and so on is a superset of nk, which is equal to E. Each ni is normal subgroup of ni minus 1 and each ni minus 1 upon ni is abelian group. By the theorem, G by n is abelian if and only if n is a superset of G dash. So ni is a superset of ni minus 1 dash. So n1 is a superset of n0 dash, which is equal to G dash. So n1 is a superset of G dash, but n2 is a superset of n1 dash, which is equal to G double dash, which is equal to G2. So n2 is a superset of G2 and so on. Nk is a superset of nk minus 1, which is a superset of G to the power k. So nk is a superset of Gk. So E is equal to nk is a superset of Gk, and G to the power k is a subset of E, but E is a subset of Gk always. So Gk is equal to E. बस यही हमें प्रूफ करना था.